Alrighty, let's have a look at this. Modeling with exponentials. So why exponentials are really useful? Well, they can model growth and decay really, really nicely. And when we reflect them, they can also do some other interesting sorts of behavior. So sometimes we're going to be given a model, or sometimes we're going to have to develop a model using an exponential function. Now, exponentials are annoying because there's lots of different ways of representing the same thing. So often you'll be given a format for the function as opposed to choosing it yourself. Let's have a look at it. So bacteria are a single-celled microorganism that reproduce by binary fission. Depending on the temperature and the food supply, the number of bacteria can double very quickly. The number of bacteria can be represented by nt, so a function of t, equals n naught times 2 to the kt, where n naught is the initial number of bacteria, t is the number of hours after the growth begins, k is the number of times each bacteria can reproduce in an hour. So there are 15 salmonella bacteria on a piece of raw chicken when it is taken out of the fridge. The number of bacteria double every half hour at room temperature. Determine the value of n naught. So this piece of information says 15. Well, 15 is representing n, the number of bacteria, because it says there's 15 bacteria. So what we can say is that n at some point gives us 15. But in fact, we know the time as well. What's time does that happen? Well, that only happens when it is taken out of the fridge. Okay? So that's going to be 0. So what we know is we've actually got a point. We could represent this as the point 0, 15, right? Where t is our x variable and n of t is our y variable, or we can write it using function notation. Either way, this gives us a piece of information. Let's substitute it in and see if it can tell us anything about the function. So, sub n of 0 equals 15 into the equation. Well, since n of 0 is n of t, that means we're going to get 15 on the left-hand side, n naught times 2 to the k times 0. K times 0 is 0. 2 to the 0 is 1. And so we get that the value of n naught is 15. In fact, we didn't need to do any of that calculation because, as it says in the question, n naught is the initial number of bacteria, and it says 15 bacteria on a piece of raw chicken when it's taken out of the fridge. So we didn't actually need to do that to work out n naught, but it's good to know how to do that. Determine the value of k and rewrite the equation by substituting the values of n naught and a. I believe this is meant to be ak, since there is no a value. So it tells us that k is the number of times each bacteria can reproduce in an hour. And then down here it tells us that the number of bacteria double every half an hour. So since there are 2 half an hours in an hour, that means that it's going to reproduce twice in 1 hour. So k is going to be equal to 2, which gives us an equation. N of t is equal to 15 times 2 to the 2t. And now we've got a full-on equation, and now we can actually start using it. Once you've got a complete equation, you can either substitute in n, our y variable, or t, our x variable, to work out the other one. So we've now got a complete equation. So let's have a look at C. How many bacteria are present after 2 hours, after 10 hours? So after 2 hours, that's when t is equal to 2. So what we're going to be looking for is n of 2. Since our equation is 15 times 2 to the 2t, it's going to be 2 times 2, which is going to be 15 times 2 to the 4. 2 to the 4 is 16. 16 times 15 is going to be 240. One way of doing repeated multiplication like this is to actually double 4 times. So you can think about double 15 once is going to be 30, then 60, then 120, then 240. A little bit easier. But at a certain point, we're probably going to be using our calculators to do a lot of this stuff. So to work out after 10 hours, well, that's going to be t equals 10. We're going to get 15 times 2 to the 2 times 10. And this is certainly not human workoutable. After a brief trip to calculator land, we come back with 1572864. Put in our commas, and we can read that as 15,728,640. So there'll be 240 bacteria after just 2 hours, and then after 10 hours there will be 15 million, over 15 million bacteria. You can write a little sentence. I'll leave that for you lot. So the last question is, how long does it take for there to be 750 bacteria present? Well, it's certainly going to be more than 2 hours, but it's going to be less than 10 hours. And same thing again for a million. Well, we know it's going to be more than 2 hours, but less than 10 hours. So we're looking for 2 answers in between these ones. So let's have a look at D. So D, now we know that for what t value does n of t equal 750? Well, 750 goes on the left, 15 times 2 to the 2t, and we're solving for t. Divide both sides by 15. Now, 750 divided by 15 may sound scary, but 75 divided by 15 is not so bad. 75 is 15 times 5. So it's going to be 50 is our answer. And then we get 2t on the right-hand side. Take the log base 2 of both sides. That cancels the 2 on the right-hand side. Log base 2 of 50. 50 is not actually a power of 2. The closest power of 2 would be either 32 or 64. So it's going to be somewhere between those. But in this case, we're probably going to be using a calculator. So we get log 2 of 50 equals 2t. Now we're going to divide both sides by 2. And that's going to give us the value of t. So log base 2 of 50 divided by 2 is equal to t. And using our calculator, just as a reminder, I would be using the log AB button, which again, if you click F4 on your calculator, that's going to bring up the math menu, and log AB is F2 on that. So in this case, it takes about 2.82 hours. Or, more likely, we probably want to write this as either rounding to hours, so just 3 hours, or if we wanted to do it to minutes, it'd be 2 hours and 0.82 times 60 minutes, which is 49.2 minutes. So you could either say 2 hours and 50 minutes, or you could say 3 hours, or you could say 2.82 hours, depending on what the question's asking you to do. Next one. When, for what value of n of t, is this equal to 1,000,000? That's the second part of the question. So, once again, 1,000,000 on the left-hand side. Now it's going to be the exact same bit of algebra, so divide both sides by 15. In this case, I'm not going to even attempt to simplify because there's no real point. Oh, not t to the 2t, 2 to the 2t. Take log base 2 of both sides. And then divide by 2. And that's going to give us our answer. So in this case, and I'm just going to put this all in the calculator in one go. And you should be getting 8.01 hours after rounding. So it's going to take more than 8 hours. And again, you could take that 0.01 and convert that into minutes by timesing it by 60. So there we go. There's our first example of modeling with an exponential function. And once you've got the function, then you can substitute in either your x or y variable to find the other one. See you in the next one. Goodbye.